Hello and welcome to T&D World Live. I am the avatar for Eric Smith, Operations and Reliability Engineering Supervisor at Georgia Power. My responsibilities include power delivery at critical facilities like Atlanta's Hartsfield-Jackson International Airport, the Mercedes-Benz Stadium, the State Farm Arena, and the underground power distribution network for metropolitan areas throughout Georgia, referred to as Network Underground. Ensuring reliable power at the world's busiest airport is a priority for my team of test engineers and technicians. During the next few minutes, I will be presenting the results of our ongoing work to increase safety and reliability of the underground power delivery network serving Atlanta's Hartsfield-Jackson International Airport. The December 2017 airport power outage had global repercussions. With over 1,000 flights canceled, tens of thousands of passengers were affected in airports around the world. According to reports, the total cost of the outage can be approximated at over $95 million to all parties involved. This includes direct costs to airlines and passengers, as well as indirect economic impacts on airport operations and local businesses. The entirety of the underground power delivery system at the Atlanta airport consists of over 2 miles of tunnels containing over 18 miles of power transmission cables with hundreds of splices. The outage originated in the tunnels beneath the concourses, where the resulting fire and extreme heat destroyed the physical evidence of the origins of the fault. However, ailing splices and connections account for the majority of power system failures, and the likelihood of failure increases dramatically with age. That's what led to Georgia Power's decision to employ infrared automation technology to continuously monitor the integrity and condition of every splice and connection in the airport's tunnels. Prior to the 2017 outage, periodic manual inspections were performed by a team of trained thermographers utilizing handheld instruments and manual inspection protocols. These protocols are time and labor-intensive tasks which are prone to human error and are likely to detect only the latest stage failures, and just as likely to miss transient anomalies that can provide reliability engineers early insight into degrading conditions. The large number of splices and connections present serious operational challenges to periodic manual inspection methods, given the time and effort required to individually measure and record the temperature of each one. Prior to adopting automated measurement and analysis, a 3-man thermography team would perform a full annual survey of every splice and connection in the tunnel network, requiring approximately 3 months to complete the task. As a result, the period between inspections of any given splice or connection could be many months, leaving ample opportunity for faults to develop undetected. In the wake of these events, Georgia Power immediately undertook the task of identifying technologies that could be employed to provide continuous measurement and early warning of degrading conditions, including early trials of numerous infrared cameras and automated thermography solutions, none of which provided the level of functionality desired by Georgia Power. Georgia Power then consulted with Dr. Purvi Patel of the Electric Power Research Institute's Lennox Laboratory for evaluation of possible technical solutions to the problem of monitoring such a vast complex of cables and connections. Working with engineers from Georgia Power, EPRI constructed a test jig using known bad cable splices and switches of the same make and model used in the airport's underground tunnel complex. Infrared cameras were placed inside the test chamber and configured to monitor temperatures at the splices and connections using a patented radiometric analysis system provided by Power Intelligence, and results were compared with other vendors under consideration at the time. While all of the tested solutions reliably detected and identified terminally defective cable splices, reliable detection of this most extreme condition by itself was not enough. Any solution capable of monitoring such a large and critical facility as the Atlanta airport must also be scalable to handle hundreds of cameras at multiple locations, and to prove compatibility with existing communications and data infrastructure, including secure network access, traversing firewalls, and providing end-to-end encryption of all data to be stored in a centralized database for analysis and sharing with stakeholders and systems of record. A thorough evaluation of all competing sensors and solutions was performed on the basis of the following criteria: sensitivity to temperature changes and reliability of detection, efficient use of network resources, i.e., no continuous streaming or UDP broadcast of radiometric data, secure communications via end-to-end encryption, support for Active Directory enterprise user access control, secure user web access to real-time and historical measurement data without the need for a desktop app, centralized database recording historical radiometric images from each camera and measurement data for each splice and connection, support for SCADA automation protocols, including Modbus and DNP3, deployable via virtual machine running on Georgia Power data center infrastructure, and perhaps most important, intelligent analytics to help identify developing faults through machine learning, statistical analysis, or other methods. Ultimately, Georgia Power selected the Power Intelligence Power Intel system for deployment at the Atlanta airport and has now adopted Power Intel for network underground critical facilities. On a related note, in January of this year, Power Intelligence was awarded a United States patent for their Sigma Delta Tau radiometric analysis algorithm, which has repeatedly detected and identified suspicious transient temperature anomalies occurring at increasing magnitude and decreasing intervals, with 2 such occurrences in the last few months. Today, over 100 radix thermal imaging cameras manufactured for Power Intelligence by Planck Vision Systems are installed throughout the network of tunnels underneath the airport complex. These cameras have proven to be extremely reliable. In the 3 years since their installation, we have not experienced a single camera failure. The cameras connect over local networks to distributed processors which collect, encrypt, and retransmit the radiometric data over fiber optic networks to a master server located in the Georgia Power data center, where analysis and reporting functions are performed. In the 3 years since the Power Intel system was commissioned at the Atlanta airport, it has made several early detections of degrading condition in connections, splices, or switchgear with no false positives. In fact, every detection by the Power Intelligence system has been verified by manual inspection and remediated without incident. In several cases, the analysis performed by the Sigma Delta Tau algorithm revealed a repeating and increasing pattern of transient anomalies, which left unchecked could easily have led to a full-fledged failure. This chart depicts the life cycle of a fault from the early transient stages through to the point of functional failure. The success of the Power Intel system at the Atlanta airport demonstrates the value of continuous monitoring and the power of predictive analysis to increase reliability while dramatically reducing costs and risks to personnel and facility operators. Building on this success, we are now expanding the Power Intel system to include other facilities where it will also provide coverage of the transformer vaults and switch gear. These new installations will leverage the same network and computing infrastructure already in place since the airport project. In conclusion, our experience with the Power Intelligence system over the last 3 years has built confidence within Georgia Power and Network Underground in the technology, the implementation, and the company. And we have demonstrated an even greater return on investment than what was envisioned at the onset of the airport project. In fact, the price of implementing the Power Intelligence system was just a small fraction of the overall costs of the 2017 outage, and its performance reinforces our commitment to utilize this leading-edge technology to increase safety and reliability at network underground facilities. Thank you for your time and attention.